Okay, welcome to the next video. We're going to develop the unit circle using degrees. So remember that we always start with our angle and standard position. We're going to start at that positive x-axis. So that's going to be the initial side of our angles, of our rotations. So if I don't move at all, I'm at 0 degrees. And if I go all the way around the circle, I'm at 360 degrees. And now we're going to start cutting things in half. So we cut the 360 degrees in half, and that gave us 180 degrees. We took the 360 degrees and we cut it into fourths. That's going to give us 90-degree rotations. So that's going to give us 90 degrees for our first turn. Another 90 gives us 180. Another 90 would give us 270 degrees. And then the final 90 would give us 360 degrees. Then we took that, let's just go back and look. Then we took that 360 degrees and we did the 1/6 of a revolution, which is 60 degrees. Rather than do the 60 degrees, I'm going to focus on, let's do this in orange. I'm going to focus on the 1/8 of a revolution. Actually, it's not in blue. So I'm going to focus on the 1/8 of a revolution, which is 45 degrees. And then I'm going to focus on the 1/12, which is 30 degrees. So I'm going to show you this in the colors. Let's do the cutting it into eighths. So if I were to cut that, now that's into fourths, so I need eighths. 8 equal parts, 8 equal parts. So there we've got 8 equal parts. 1, 2, 3, 4, 5, 6, 7, 8. So we've got 2 in each quadrant. So that's taking 360 degrees and dividing it by 8. And when we did that, we got 45 degrees. So 45 degrees for our first turn plus another 45 is 90. And I'm working this way. Another 45 is going to give us 135 degrees. Another 45 brings us to 180. Another 45 is 225 degrees. Another 45 is 270. Another 45 is 315 degrees. And then the last 45 is 360 degrees. Then we're going to take the unit circle, this circle, and we're going to cut it into 12 equal parts. So 1, 2. Now, those slices are shared, but I'm not going to be sharing any more. So here's my 12 equal parts. And I'm going to remove the blue ones. I'm going to remove the blue ones so that you can see a little bit better. And I'll bring them back. I'll put them over here because we're going to need them over there anyway. So there we go. So there's the blue ones. So we moved those out of the way. So what we have here is what I should have had here. My drawing is not perfect, but hopefully you get the idea. I've got 3 equal parts in each quadrant, so 3, 6, 9, 12. If I take the 360 and divide it by 12, I get 30-degree turns. So my 30-degree turns would be 30, and then to the next orange, right? So that's the 30 degrees, and then to the next orange would be another 30, so that would make that a 60, and then another 30 gives me the 90, right? And then another 30 gives me 120, and then another 30 gives me 150, another 30 is 180, plus 30 is 210, plus 30 is 240, plus 30 is 270, plus 30 is 300, plus 30 is 330 degrees, and then your final 30 gives you 360. And there's your unit circle in degrees. So if I were starting at 0 and I were just going around the circle and doing this in, say, 30 to 40 seconds, I would do this for degrees. I would start at 0, end at 360. I would start at 0, do plus 30, plus 15 degrees, plus 15 degrees, plus 30 degrees, plus 30 degrees, plus 15 degrees, plus 30 degrees. And that's how I would go around the circle. So 30, 15, 15, 30, 30, 15, 15, 30, 30, 15, 15, 30, 30, 15, 15, 30. So this jump from 30 to 60 is 30 degrees, but halfway in between there, I've got that 45 degree mark. So half of 30 is 15 and 15 because everything's symmetrical. Okay, now let's talk about radians. So when we've got our radians, we start at 0, we end at 2 pi. And if I cut this in half, if I cut my let's just do green. So if I cut my 0 to 2 pi in half, I'm going to get pi. And if I cut it in half again, that would be the fourths. Half of pi is pi over 2. And then I've got 1 pi over 2, 2 pi over 2, which is just 1 pi. And then I'm going to have 3 pi over 2. And then add another pi over 2 gives me 4 pi over 2. And 4 pi over 2 is 2 pi. So listen, start at 0, 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. So we start at 0, 1 pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2. So the 2 pi over 2 is pi, and the 4 pi over 2 is 2 pi. Those two reduce. And that's what's going to happen when we cut this into eighths. So now I've got eighths, 2, 4, 6, 8. So I've got 2 turns in quadrant 1 that are congruent. Another 2 turns, another 2 turns, another 2 turns. So 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to take my 2 pi, I'm dividing it by 8, and that's going to be the same thing as turning pi over 4. So I've got 1 pi over 4, which I just call pi over 4. So I do not include that 1. And then I've got 2 pi over 4, but 2 pi over 4 reduces to pi over 2. Then I've got 3 pi over 4, and then I've got 4 pi over 4, but 4 pi over 4 is the same thing as 1 pi. Then I have 5 pi over 4, and then I have 6 pi over 4, which reduces to 3 pi over 2. And then I have 7 pi over 4, and then I have 8 pi over 4, which reduces to 2 pi. So we're done cutting that and doing those halfway marks. I'm going to move these out of the way and eventually delete them. Now let's cut this into our 12s. So 1, 2, no, not. 3, 4. Okay, I'm gonna make this as good as I can. There we go. So when I take my 2 pi and I divide it by 12, that's going to be turning pi over 6. So I'm going to do this in red so that you can see. We start at 0, and then each turn is going to be a pi over 6. So 1 pi over 6, 2 pi over 6, which reduces to pi over 3. 3 pi over 6, and I should, let me go back. I should make this one orange so that you can see, and that one orange. There we go. So here's our 1 pi over 6, 2 pi over 6, 3 pi over 6. 3 pi over 6 is the same thing as pi over 2. And then the next one is going to be 4 pi over 6. And 4 pi over 6 reduces to 2 pi over 3. And then we have 5 pi over 6, which does not reduce. And then I have 6 pi over 6, which reduces to pi. And then 7 pi over 6. And then the next is 8 pi over 6, which reduces to 4 pi over 3. And then 9 pi over 6, which is just 3 pi over 2. And 10 pi over 6, which reduces to 5 pi over 3. And then 11 pi over 6, which does not reduce. And then 12 pi over 6, which is just 2 pi. I'm going to clean this up in just a second, but you have the luxury of slowing me down and making me repeat myself. So make sure that you go back and re-listen to where things came from if you need to. I'm going to delete all of this, and I'm going to show you how I do this. So I start at 0 and then 2 pi, and I do all my axes. So I know that up here I've got 1 pi over 2, or just pi over 2. I've got pi and 3 pi over 2. And then of course we end at 2 pi, which I already wrote. And then I'm going to do the ones in the middle. So the ones in the middle are my pi over 4s. And they're going to be all the pi over 4s that don't reduce. 1 pi over 4 does not reduce. 2 pi over 4 reduces, it's up here. 3 pi over 4 does not reduce. 4 pi over 4 reduces, it's right here. 5 pi over 4 does not reduce. 6 pi over 4 reduces, it's right here. 7 pi over 4 does not reduce. 8 pi over 4 reduces, it's right here, it's 2 pi. So 1 pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. I literally go through that in my head. 1 pi over 4, and then this one I'm like 2 pi over 4. Nope, that reduces. 3 pi over 4 would be next. That's my next halfway angle. Okay, halfway in a quadrant. So when I say my halfway, I mean halfway in the smack dab middle of the quadrants. Those are your pi over 4s. Now I'm going to have my pi over 3s. Your pi over 3s are going to be closer to the x-axis. So your pi over 3s, again, are going to be all the pi over 3s. I'm sorry, your pi over 3s are going to be closer to the y-axis. So let's do the pi over 6s. Pi over 6s are going to be these 4 angles right here. So pi over 6s are going to be these 4 angles. They're going to be closer to the x-axis. And they're all the pi over 6 angles that don't reduce. So 1 pi over 6, 2 pi over 6 reduces, 3 pi over 6 reduces, 4 pi over 6 reduces, 5 pi over 6 does not. That's your next angle that's closest to the x-axis. The next angle that's closest to the x-axis in quadrant 3, 6 pi over 6 reduces, 7 pi over 6 does not. 8 pi over 6 reduces, 9 pi over 6 reduces, 10 pi over 6 reduces, 11 pi over 6 does not. Then we've got our pi over 3s. Those are going to be the angles that are closest to the y-axis. So 1 pi over 3 does not reduce, 2 pi over 3 does not reduce, 3 pi over 3 reduces, 4 pi over 3 does not, 5 pi over 3 does not reduce. And that's your unit circle. And that's how I draw the unit circle every time I need to for speed. So you should be able to do both of these in about 40 seconds or less. So less than 40 seconds. Less than 40 seconds. So practice that. In the next video, we're going to talk about the quadrants and determining which quadrant we're in and estimating amounts of rotation.